Dear students, I welcome you for the special practices component online recording session for the industrial robotics course. So, in the process of learning the practical part, so earlier we just dealt with 5 presentations, and this is the last presentation which does with the work of palletizing and depalletizing program. Okay, so with this palletizing and depalletizing program, we'll be closing down the online learning part. Okay, so now we'll directly get into the work. Program an articulated 6-axis robot to palletize or depalletize is going to be the default task. So before we get into it, we'll understand what is pallet, what is palletizing, and what is depalletizing. So all these terms we'll learn in this presentation. See, this is what a pallet is all about. Okay. See, what is a pallet means? It is a small elevated platform. So usually the standard sizes are like this. So the length will be 1000 mm. It will be 1000 mm. That is 1 meter by 800 millimeters. This is what Indian standard pallet size. Okay. And the height will be 200 mm. So now what is the thing is, you can understand these all are the planks of wood. See, even it need not to be wood, even plastic pallets are also available. So usually 99.9% it will be made out of wood or plastic. Now you can see there is a recess. There is a recess throughout the thing. So this is going to facilitate a material handling device by name forklifter. There is an forklifter material handling device. So now what is the thing is, say for example, this is the floor surface. Now you have got a bulkier object. Unknowingly, you kept the bulkier part, some machine or some metal, something like that. Now will it be easy for us to lift? Definitely not. Suppose if the same case, you are just doing like this, you have kept some rock or something, some brick or something, and then you are placed. Now will it be easy for us to lift this particular part? Why? Because there is a gap. Now that's the purpose of this gap. It will be able to easily lift. We'll be able to easily lift, and above this we'll be able to place the component. So now we'll see the forklifter loading the part. So this is what the forklifter. So you can see there are tongs are there. So this tongs, what it does is it nicely enters within this. Okay, and it will be able to lift. How it lifts means like this. Okay, so here you can see. So this is how that pallet helps us to keep. So now you can keep elsewhere, and again it will be easy for us to lift. So it is going to facilitate easy material handling. So that is what pallet is going to be the function. Now, what is palletizing means? It is a process of stacking the products in particular cases by means of boxes or bags onto a pallet in a very organized way. In a systematic way, we just organize everything. So one part is called as unit load. So we'll be nicely organizing it, and depalletizing means same. It has been packed and that you are going to remove it into individual. So from one by one you assemble. Okay, so from a part you just go it into a big box. This is called as palletizing. Okay, from the big box you just make them into individual part, depalletizing. So palletizing opposite is depalletizing. Now with respect to program, will there be any change? Means obviously there will not be any change. It will be only simple change. So from where, how do you start and how do you finish? That's the only thing. Okay, so we'll see how to do such program in a robot. So this is the pallet, but here what is the thing is, here we don't consider the thickness, or the thickness is negligible. Here we consider this as a plane. So we consider this entire surface it as a plane with negligible thickness. So now how do we plan us like this? See, how to define the points, how to determine the coordinates. Everything is based on our planning. So the planning should be very sincere. So how this presentation will help you how to plan. And now define how many rows and columns you are going to have. Now immediately there might be a doubt. I have a doubt in understanding what is row, what is column. I will take you simple row, and this part I will have column. Okay, column. So row, left to right, left to right. So here which is the left and which is the right? So this is the left and this is the right. Clear? So whichever is going from left to right like this. So how to remember? R right and here R row. So this is the mnemonic. So left to right, how many are going? You just look into the system. So here, this is number 1, and this is number 2, and this is number 3, and this is number 4. So row number 1, row number 2, row number 3, and row number 4. So there are 4 rows over there. Okay, so it is easy for us to understand. So row means left to right. Okay, now next thing, column. See, column means climbing, steps, climbing. Okay, climb. Now this is C, this is C. So here, how many you are going to climb here? You just understand, climb from bottom to top. Bottom to top, when you take, it is going to be 1, 2, 3, and 4. Okay, so that is how we will be looking into it. So bottom to top. Bottom to top, how many paths are there? So path 1, path 2, path 3. So 3 steps are there for you. That is 3 spaces are there for you to climb. So therefore here it is having 3 columns. So rows, comma, columns. That is the understanding. Rows, comma, columns. Okay. So here there are 12 spots are there. So how do we get the 12 spots? Is 4 by 3. So 4 rows and 3 columns. Okay. So this is how we are going to understand. And one more thing is also there, columns. When you construct your home, so there will be pillars will be there like this. Clear? So above this only we are going to construct the house, or within which we'll be giving car or something like this. So even this is also called as column only. So likewise also you can remember. Now in this robot programming, the important task is how are we going to do the palletizing part. Say this is the first space. This is the first space. How you are going to arrange. Now I am going to arrange. I wanted to arrange like this. Say number 1. This number 1 means I wanted to arrange like this. From here we'll go to this part. From here we'll come to this part portion like this. Clear? When you crisscross, when you come and go, so this is pattern 1. Now pattern 2. Pattern 2 means, I'll erase. Pattern 2 means from here we started, so I'll just make it as zigzag. Pattern 2, left to right. Clear? Again, from here the robot will migrate to here. So left to right. From here, left to right. From here, left to right. So likewise when it goes, this is called as second pattern. Okay. There is another pattern called as third. It is called as circular. So this is called as a linear pattern. Always from left to right. Circular means it will be like this. Yeah. 1, 2, 3. Circular. So this is point 1, point 2, point 3, point 4. So from here. So next. Circle. So likewise it goes on. So here r theta will be used. So this is third pattern. So these two will be using it on the pallet. So this will be used when you go for some cylinders or something like this, within which you wanted to arrange the part. So under those cases we go. So this is based on polar coordinates, and this is based on Cartesian coordinates, that is x comma y. Okay. So how to define the points? So points definition will be like this. See, you have got a pallet. You plan in such a way that, see, all the cases there should not be 4 rows and 3 columns. There is no hard and fast rule. Only you plan. It is based on your. So this hatched portion is the box size. So this is the unit part. And these all are the 4 corners. Why? Because these 4 points we are going to specify in the program like this. Now, this is the 4 extreme points, but not these corners. It is the center points of the 4 extreme loads, unit loads. When you keep in the boundary, so these all are the 4 extreme points, and for that we should have the coordinates. You have the coordinates in whichever the passion you want. P1, P2, P3, 4, or you can have this P2, something like that. So here the boundaries of the pallet means this is what the boundary. P1, P2, P3 and P4 is the boundaries of the pallet. Clear? So these all are the 4 points what we are going to define in the program. Okay. The next case. Earlier we discussed palletizing. Now, how many points should I specify? First, you have got P home. Somewhere P home is there. Now, from this spot, you wanted to go across all these spaces. Okay. From here to there, if you go, it is palletizing. And vice versa. From all these points, you bring to this particular P5, then that is called as depalletizing. So 99% the program is going to be the same. So only difference is from how you start and how do you end. Based on that, the difference will be there. So from one point you take to the rest of the point, it is palletizing. From all these points you bring to this point, then that is called as a depalletizing. Okay. So with this understanding, we'll start the program. So now we'll do the program part. So I'll make a very simple sketch here. So this is the P5 and this is the P home, and these all are the 4 corners of our palette. So now we discussed in the earlier slides how to define them. So I'm taking this as P1 and this as P2 and this as P3 and this as P4. Okay. So I'm going to do a palletizing program. So now what will happen is here we are going to mix all the learning elements what we had in our earlier presentations. That is, we are going to use if-then programming, as well as we are going to use gripper, that is a tool pick and place, as well as palletizing. Everything we are going to use it up here. Okay. So how we'll just go ahead with. So the first step, foremost step is we know the initial opening ceremony. So move P home. Okay. So the moment you do, we are supposed to define the palette. So how that palette is defined, PLT1. Okay, palette 1, comma, P1, comma, P2, comma, P3, comma, P4. Okay, I'll finish it, then I will explain. 4, comma, 3, comma, 1. So this is the statement what we do. So this particular statement governs with palette definition. So palette, we are defining the palette in this particular case. So define palette, DEF palette PLT1. This palette number is 1. Okay. P1, P2, P3, P4. Okay. So these all are the 4 boundaries of the palette. So we know it is not the boundary, it is the midpoint of the 4 unit parts which is going to occupy in the 4 corners of the palette. 4, 3 is the 4 rows and 3 columns, and 1 is the pattern of arrangement. So we learned on the earlier thing. So zigzag, if you go with the 2, it is going to be linear from left to right. That is what the case is all about here. So palette is over. So now what is the thing is, we can open up a loop. What is the loop? We can go ahead here is, the loop is like this. Or before we open the loop, you might be having a doubt. Why should I open a loop? I'll tell you what is the reason. So this particular palette is going to be a part of this activity. See, 12 times this work is supposed to carry out, right? So 12 times at different position it is going to carry out. So for that we are going to use this particular, without loop also we can do. So I'll just to show you how to go ahead with this. So now you know how to go ahead with, that is P5. So first step is we are doing palletizing. So therefore MVS, so P5, so alpha point, so minus 100. Now the robot as nicely comes and it is going to be on the alpha point of the P5. So it is in the safety point. So now M underscore out 15 is equal to 0. If the gripper has not opened, we are asking the robot to open up the gripper to hold the part. So now what is the next thing? So MVS P5. So now the robot is into the base point and we wanted the robot to hold the part. M underscore out, okay, 15 is equal to 1. Now the part has been picked up. Now Now the next thing is, we know it is supposed to be override. So override by 50%. What are the thing the robot is having? We are asking the robot to reduce the speed by 50%. Once the speed is reduced, now it is nice. Now we are asking the robot to go to the point P1. So P1 is MVS safety point, no? So P1 comma minus 100, that is P alpha 1. So it is exactly about this particular point. It is supposed to release the part at P1. So MVS. See here you want, even we can add delay statement here. See this particular point, if you want delay we can add. I have not added citing space. Here I don't have sufficient space, therefore I have not added. So MVS P1. Now it is in the P1 point. So now what we are doing is, we are asking the robot to unload the part at that particular case. So now we can have delay. Why? Because unloading, no? So delay. Then again we can remove the override. Override can be made to 100. Now this is the first task. See, likewise should we do for the next all this thing? Means no, it is not necessary. Okay, what is the next step you are going to do is, M1 is equal to M1 plus 1. So this statement is important. Whatever the task you did as of now, we are asking the robot to put it into M1. Okay. Then with that add an increment. Whatever the thing you did is M1 and add to it, because one part has been finished. P1 has been finished. Now another how many points it is supposed to go? It is supposed to go for, similarly for next 12 points it is supposed to go. Okay. So next we'll write the next statement. M1 is equal to 1 to 12. That's it. For other points we need not to specify. Obviously the robot will take care of this. So once all the work is over, we can end the program. Okay. So this is how we do the palletizing program. So what is the thing is, from P5 we came to P1. So it will be reverse. Okay, from this point you come to P5, then that becomes depalletizing program. Okay students, so with this understanding we come to the end of the series of online presentations for the practices component of industrial robotics. Okay, so thank you one and all.